Making a computer chip is probably the most complicated process in the world.
It takes thousands of engineers, hundreds of multi-million-dollar tools, factories the size of 4 American football fields, and billions of microscopic switches called transistors. And before a working chip winds up in a PC, data center, or another computing device, it goes through a battery of temperature, stress, performance, and quality tests.
We're about to show you a few of these fascinating tester tools. Come with us as we go behind this door. We're in a high-volume test factory in Oregon.
It's part of Intel's Assembly Test Technology Development Group, or ATTD. ATTD is one piece of Intel's manufacturing juggernaut. Here, engineers research and develop the latest testing equipment and processes before they pass them on to our high-volume manufacturing factories that test chips by the tens of millions every day. This tool is called a sort module. It's the size of a small school bus. It's made up of 20 individual test cells, each about 5 by 5 feet square. Inside each test cell, thousands of chips are sorted and tested to check for defects and measure their performance. Each test cell weighs about 1,000 pounds. At times, cells are removed from the sort module with a custom-designed lifter mechanism. The lifter is moved around the floor by this TC runner, which floats on a cushion of air like a hovercraft.
Without this runner, the tester and the lifter are so heavy they would literally destroy the factory floor.
This device is called a probe card. The probe card physically touches the chip to connect the integrated circuits inside to the test equipment. It measures the electricity of the chip's circuits for reliability and defect analysis. The probe card uses small micrometer-sized metallic needles to connect with contact pads on the chips. Some products may require as many as 20,000 probing needles in an area of just a few square centimeters.
Each probe needle is thinner than a human hair.
Once good chips leave Oregon, they're sent to Arizona to be assembled between a heat spreader and a substrate. This package protects them and connects them electronically to a computing device's circuit board. Behind this door in Arizona, packaged chips undergo even more quality checks. On a side note, some of Intel's most valuable tools live here as well. They manufacture our advanced packaging inventions called EMIB and Foveros, which allow us to interconnect multiple chips on a single package. These machines give Intel its packaging leadership. Now back to ATTD. The 3 test modules and software you are about to see are all designed by Intel engineers. This is the high-density burn-in module. There are so many chips tested per cell and so many electrical pins per device that this tool must provide an exceptionally large socketing force, about 3 metric tons. That's the equivalent of a Chevy Suburban on top of each cell.
That's a lot of force.
Like Oregon's sort module, this massive tester checks the speed and performance of the chips at extreme temperatures, from 110 Celsius to as low as minus 40 degrees Celsius. The final step in the test flow is system test, where each packaged chip gets socketed to a motherboard to simulate real-world customer conditions. This tool runs chips on different operating systems such as Windows and software and graphics applications to ensure our final products work for customers. You are most likely watching this video on your computing device, a device being run on a chip that underwent thousands of manufacturing steps and hundreds of quality tests. Hope you enjoyed going behind this door with us.
Thanks for watching. I'm Rob Kelton.